Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question submitted by a student. This is from Algebra 1, and we're going to graph the solution region for this system of inequalities. We're supposed to be testing specific ordered pairs, but those didn't appear in the question, so we'll just graph it. I'm going to start with this bottom one here, because it's already in slope-intercept form. So when x is 0, y is -5 here, you can see that's a 5. And when y is 0, x is 5/4. So that's 5/4. I'm just going to get the two intercepts. You see, that's the easiest way. So when x is 0, y is -5. And when y is 0, x is 5/4. And now I'm going to connect these two using a dashed line. I'm using a dashed line because this inequality has no equal sign in it, see? So here we go. Here's our dashed line. Not very pretty, but it'll do. And now we want to shade, and we need to decide, do we shade above the line or below the line? And the way I like to handle that is to use a point, and I'm going to always choose the origin if it's available to me. If the line goes through the origin, I cannot use the origin, but I'm going to use the origin here. And when I plug 0, 0 in here, I get 0 bigger than -5, and that is true, which means the solution region includes the origin. So I'm going to shade the solution region like this. It includes the origin. And there you go. So that's this bottom one here. We could put a color code there if we want. Now for the top one, I'm just going to rewrite this. So y is going to be greater than -x plus 6, just to make it easier to graph. So when x is 0, y is 6. So 6 looks like something like that. And sorry, when x is 0, y is 6. When y is 0, x is +6, which is over here. And now I'm just going to connect these two with a dashed line, pretty much the way I did earlier. So there's my dashed line. And now I'm going to shade this. So I'm going to use 0, 0 again. I'm going to get 0 greater than 6. And that's false. And so I'm going to choose another color now and shade the solution region. We'll use blue. So the origin is not included here, so the solution region for this guy is up here, because we have to exclude the origin. And it looks like that. You can extend it up. You can extend it up as far as you want. Same thing with the green. Let me extend the green a little bit more. Can extend this. And so the solution region for these two things, oops, that green should not have been extended that far. I got carried away there. should only go down to the black line, which isn't quite there. Okay, so the solution region for both of these combined is the intersection of the blue and the green. And I'm just going to put a big fat R here, just the way I like to indicate a solution region. Now, any coordinate point that falls in the solution region is a solution, obviously. Any point that falls outside the solution region is not a solution. And so you could have tested a particular pair by determining whether the pair lies in the solution region or not. Or you could test a particular pair by plugging them back in to the original inequalities. Either way will work. This can also be done on your graphing calculator. The graphing calculator is capable of graphing inequalities and shading the regions automatically. So that's something you might want to look into. Another option would be to graph this online using an online grapher, which I did as well. And I want to show that to you. And we'll just bring that in here and size it. And the colors are not the same. This red region is actually the blue on my diagram, and then this blue region is the green here. So the colors don't match up, but you can see that the shape of the solution, this is the solution region in here, and the shape is a V here, a V shape. And you can see over here on the graph we did by hand, it's a similar shape. And it's just this one that was done by hand is not drawn to scale, obviously. Okay, so you can use graphing paper and colored pencils, which is essentially the equivalent of this. Or if you're allowed a grapher, you could use an online grapher, or you could use your calculator. Either way, you end up with this. So I think it's a good exercise. You just have to be really, really careful about dotted lines versus solid lines, and you have to be careful of shading above the line versus below the line. It's easy to make a mistake, but it's really not that difficult. You just have to be really careful. So that's it for this lesson. I'll see you guys again next time. Bye-bye.